Hi everyone, my name is Alan Thomas and my seminar presentation is about the topic fiber optic technologies and its advancement and was guided by Assistant Professor Vijay Lakshmi Ji. The content I am explaining in these session are introduction, history, elements of fiber optic communication, working principle of fiber optic communication, components and working principle of fiber optic cable, advantages and disadvantages of optic fiber cable, applications, advancement in fiber optics, future of fiber optic technology, companies involved, conclusion and references. Coming to the introduction, optical fiber communication, as we all know, is a method of transmitting information from one point to another by sending pulses of light through an optical fiber. Optical fiber is a flexible transparent fiber and it is made up of high quality extruded glass or plastic. These are alternatives to conventional cables such as copper cables and coaxial cables. Then we can look into the history. In 1854, a scientist named John Tyndall proves that the light signal can be sent. And coming to 1880, Alexander Graham Bell created photophone, which actually sends audio messages via a light beam. In 1916, British physicist Charles K. Cavo theorized that pure glass could be used to transmit light signals over long distance with minimal loss. In 1970, single mode fiber soon became the backbone of long distance telecommunication networks. And coming to the 1990s, new technologies such as wavelength division multiplication, which is based on optical fiber communication, were introduced. In 2010, fiber to the home broadband internet connection technology that uses fiber optic cables to transmit data becomes common. Coming to the 2020s, latest advancements such as orbital angular momentum radio over fiber were introduced. Then we can look onto the block diagram of a optical fiber communication. As we can see, at the transmitter side, primarily the analog signals are converted to the digital pulses via an analog to digital converter. And these converted digital pulses are then transmitted via a light source. That light source undergoes total internal reflection inside the fiber optic cable and get transferred. And we can look at the receiver block. The light source is collected and it is converted and shaped to the original digital pulse, and then it is transferred to the converted to the original analog signal. These are the basic principle of optical fiber communication. First, the digital signal is modulated to the light beam, and this light beam is then transmitted through cable from light source emitter. The light beam undergoes total internal reflection inside the fiber optic cable. At the receiver side, the light beam is amplified and demodulated and shaped. It is then converted into its original digital signal form, and final output is obtained. Then we can look to the fiber optic cable. It mainly consists of two parts, core and cladding. And the data transfer is works on the principle of total internal reflection. Also, the core and cladding are covered with a coating known as outer jacket. Then we can look into the components of a brief explanation about the components of a optical fiber cable. Mainly there are two components, core and cladding. Coming to the core, core has higher refractive index, and core carries the light and it is the smallest part of the cable, whereas cladding has relatively lower refractive index as compared to the core. It surrounds the core and it is a thin layer that enables data to travel through the length of the cable. And we can look into the materials used in manufacturing optical fibers. Uh, Core material is actually silica. Uh, Most optical fibers is made up of high purity silica, and silica provides excellent transparency to light in the telecommunication. It is doped with certain materials to modify its optical properties. Cladding material is also actually a silica. The cladding which surrounds the core, it is also typically made up of silica glass. The refractive index of cladding is lower than that of the core, which helps to guide the light within the core through total internal reflection. And doping materials. The doping materials such as germanium, phosphorus are used. The silica glass in the core may be doped with certain elements to modify its refractive index. Germanium and phosphorus are the common dopants used to adjust the refractive index of the core, which allows for better light propagation. Coating material. Coating material is actually polymer or UV cured acrylate. Optical fibers are often coated with a protective layer to provide mechanical strength and protect against environmental factors. This coating is typically made up of a polymer material or a UV cured acrylate. Now we can look into the working principle of optical fiber cable. Inside a optical fiber cable, data is transmitted in the form of light pulses. The key principle governing the operation of fiber optic cable is total internal reflection. It is actually when the light travels from medium with a higher refractive index, that is here it is core, and to a medium with a lower refractive index, here it is cladding, and the angle of incidence is above a certain angle, the light is reflected back into a higher refractive index medium. This phenomenon allows the light to be effectively guided along the length of fiber. Uh, the angle should be greater than a certain angle, which is known as critical angle here. And also the no part of signal gets refracted or transmitted to the second medium, but instead all of the signal is retained inside the fiber. And we can look into the comparison with conventional cables such as copper cables and coaxial cables. Mm, When we compare with the conventional cables, optical fiber cables in terms of bandwidth provide significantly higher capacity for data transmission at extremely high speed. Uh, when we compare, coaxial cables offer a moderate bandwidth while copper cables have the lowest bandwidth among the three. Another notable advantages of optical fiber cable is their minimal signal loss over longer distance, which is due to the principle of total internal reflection. And we can say that they are also immune to electromagnetic interference. Coaxial cable may experience signal loss, particularly over low extended distance, and are susceptible to electromagnetic interference. Security considerations also play a crucial role in cable selection. Optical fiber cables offer enhanced security as they do not radiate signals, making them challenging to tap into without detection. Additionally, signals can be encrypted for added security. Coaxial cables offer some level of security, whereas copper cables are more prone to signal tapping and eavesdropping. And we can also look at that optical fibers are not disturbed by any external fields, whereas copper cables and coaxial cables are disturbed by external fields. Efficiency is also higher for optical cables, whereas copper cables and coaxial cables have comparatively lower efficiency. Then we can look on the advantages and disadvantages of optical fiber communication. Looking into the advantages, it has greater bandwidth, less interference, strong, reliable, and flexible, superior carrying capacity, and high level security. Whereas looking into the disadvantages, it has low power, fragility, and it also has installation and construction risk and splicing difficulties. Then we can look into the applications of optical fiber communication. Coming to the medical industry, because of its extremely thin and flexible nature, It is used in various instruments to view internal body parts by inserting it into a hollow spaces in the body. It is used as lasers during surgeries, endoscopy, microscopy, and biomedical research. In communication field, telecommunication has major uses of optical fiber cables for transmitting and receiving data and signals. In the defense field, fiber optics are used for data transmission in high-level data security fields of military and aerospace application. These are also used in wirings in aircraft, hydrophones for sonars and seismic applications. In the broadcasting field, these cables are used to transmit high definition television signals which have greater bandwidth and speed. Optical fiber is cheaper compared to the same quantity of copper wires. Broadcasting companies use optical fibers for wiring, HDTV, CAT TV, video on demand, and many applications. On mechanical inspections, on-site inspection engineers use optical fibers to detect damages and faults which are at hard to reach places. Even plumbers use optical fibers for the inspection of pipes. For decoration and lighting, the use of optical fiber in the field of decorative lighting has also increased over the years. Fiber optic cable provides an easy and economical and attractive solution to lighting projects. Then we can look into the advancements in fiber optics. First advancement in fiber optics is radio over fiber. Radio over fiber actually refers to a technology where light is modulated by a radio frequency signal and transmitted over an optical fiber link. As we can see, the main technical advantages of using fiber optical links are lower transmission losses and reduced sensitivity to noise, and also electromagnetic interference compared to all electrical signal transmission. Then we can look on the steps in radio over fiber technology. The first step is baseband signal generation. The process begins with the generation of a baseband signal which carries the information to be transmitted. The signal is typically in the form of digital or analog or electric signals. Second step is the modulation, in which the baseband is modulated to the desired radio frequency or carrier frequency. Modulation techniques can include amplitude modulation, frequency modulation, or various digital modulation schemes, depending on the application and system requirement. Third step is the optical modulation. The modulated RF signal is then optically modulated into an optical carrier. This is often done using an external modulator or a directly modulated laser. The optical carrier frequency is typically in the microwave or millimeter wave range. Fourth step is the optical fiber transmission. The optically modulated signal is then transmitted over an optical fiber. The optical fiber serves as the medium for the transmission of the RF signal over long distance with low digital loss. Fifth step is the optical fiber link. The optical fiber link may include components such as optical amplifiers to compensate for signal loss, dispersion compensators to manage signal distortions, and other optical elements to maintain signal integrity during transmission. The next step is remote antenna unit. In the remote antenna unit, the optical signal is converted to the electrical domain using a photo detector. This conversion is typically done at a device called the remote antenna unit. The next step is base station processing. The electric signal obtained from the RAU is then processed at the base station. This processing may include demodulation, signal conditioning, and any necessary digital signal processing to recover the original baseband signal. The next step is the wireless signal transmission. The recovered baseband signal is then used to modulate a carrier signal at the original radio frequency. The signal is then transmitted wirelessly using the antennas. The wireless transmission can cover the last segment of communication link, providing connectivity to mobile or remote users. The next step is antenna reception. At the receiving end, antennas capture the wireless signal and convert it back to an electrical signal. This signal is then sent to the destination device for further processing. The next step is demodulation and baseband processing. The received signal undergoes demodulation and baseband processing to retrieve the original information. This process is similar to the modulation and processing steps of the transmitting end. The final step is data output. This is the final step which involves presenting the recovered data for further process or delivery to end users. This could include routing the data to specific network nodes or feeding it to the other communication system. Now we can look into the benefits of radio over fiber. It has very low signal loss and flat frequency response across the entire frequency band. And we can see it has higher immunity to EMI and RFI and higher security against signal interception. It is also flexible and lightweight, and it has also low maintenance, simple installation and cost effective. The region where ROF uses are satellite ground station equipment, broadcast production, GPS for timings, maritime, government and defense, cellular and timing, mining and public safety and telemetry. Next advancement in fiber optics are wavelength division multiplexing. It is a technique of multiplexing multiple optical carrier signals through a single optical fiber channel by varying the wavelengths of laser light. In wavelength division multiplexing, the optical signals from different sources or transponders are combined by a multiplexer. At the receiver end, this multiplexed signal are demultiplexed, and it splits the incoming beam into its components, and each of the beam is sent to the corresponding receivers. Steps in wavelength division multiplexing are: first step is source signal preparation. It is the basic preparation of the source signal. Next is the wavelength assignment. Different data streams are assigned specific wavelengths within the optical spectrum, and each wavelength corresponds to a unique channel that carries the distinct signal. Wavelengths are typically specified in nanometers. Optical transmitters. The prepared signal are then fed into the optical transmitters, where they are modulated onto optical carriers at the assigned wavelength. This transmitters converts the electric signal into optical signal suitable for transmission over the fiber. Next step is the wavelength combining. The optical signals from the different transmitters are combined into a single optical fiber, and this can be achieved using a device called a wavelength combiner, which merges the individual wavelengths into a composite signal for transmission. The fifth step is optical fiber transmission. The combined signal is then launched into the optical fiber, and this optical fiber acts as a transmission medium, carrying the different wavelengths simultaneously. Each wavelength operates independently of the others, allowing multiple signals to coexist within the same fiber. Next step is the amplification and equalization. As the name suggests, this is the basic amplification of the uh, received signal. Next step is wavelength demultiplexing. At the receiving end of the optical fiber, the composite signal is passed through a wavelength demultiplexer, which actually demultiplex the multiplexed signals. The next step is optical receivers. The demultiplexed signal are then fed into the optical receivers, and next step is signal modulation, and the final step is data output, where presenting the recovered data from each channel for further processing or delivery to end users. The application or fields where WDM uses are fiber optics field, aircraft industries, RF avionics, SONET. The next advancement in fiber optics are OAM multiplexing. OAM multiplexing actually refers to orbital angular momentum multiplexing, in which it is a physical layer method for multiplexing signals carried on electromagnetic waves using the orbital angular momentum of the magnetic waves to distinguish between the different orthogonal signals. The propagating beams within a distinct number of phase rotation, that is OAM modes, are orthogonal to one another and create multiple orthogonal channels. Then we can look into the steps of OAM. Uh, First is the generation of orbital angular momentum. In the realm of optics, orbital angular momentum refers to the rotation of light around its axis. And specifically in the context of optical fiber cables, it is possible to impart orbital angular momentum to light waves. This is typically achieved through the use of specialized devices like spatial light modulators or phase plates. Next is the multiplexing using orbital angular momentum. It can be exploited for multiplexing in orbital optical communication. Different OAM states can be assigned to distinct channels, allowing for an increase in the data carrying capacity of the single optical fiber. This approach is known as OAM multiplexing, and it is a potential solution for addressing the ever-growing demand for higher data rates in the optical communication system. Next step is the propagation in optical fibers. This is actually the signal propagation which is done in the OAM. Last step is OAM and fiber modes. The interaction between the orbital angular momentum and the various modes supported by optical fibers is a complex aspect. Different fiber modes may exhibit varying responses to OAM, and this interaction needs to be carefully considered at the last in the design of optical communication system utilizing OAM. Now we can look into the advantages of OAM. Advantages are it increases the transmission rate in point-to-point link. This increases spectrum efficiency of future 6G wireless network. OAM actually provides new access methods called mode division multiple access, and hence it can support more number of users without use of more time or frequency resources. It also offers higher reliability for anti-jamming used in wireless communication. OAM based MIMO system is suitable for long distance communication in open area. Then we can look into the companies involved in fiber optic cable manufacturing in India. They are Drone Edge, Axe Optifiber Limited, Illumination System Private Limited, Surana Telecom and Private Limited, Mcore, Vindhya Telelinks Limited, Phenolix Cables Limited. Then we can look into the future of fiber optic technology. First, we can actually say increasing demand. As the increasing in demand for higher bandwidth is one trend that is already well underway. With the rise of high definition video streaming and online gaming, there is an increased demand for faster and more reliable internet connection. Next is network expansion. The continued expansion of 5G network is one prediction for the future of fiber optic technology. Fiber optic cables are used in 5G networks to transmit data at high speeds and with low latency. And as 5G technology becomes more widely adopted, we can expect to see more fiber optic cable deployment to support this network. Next is the material deployment, and another prediction is in the development of new fiber optic materials and technologies that will allow for faster data transmission. We also know researchers are investigating the use of novel materials such as graphene and silicon photonics, which have the potential to transform the fiber optic industry. In conclusion, we can say that fiber optic technology has greatly impacted the world in many ways, in which it providing fast internet speeds, improved communication, and advancement in various fields such as medicine, industry, and research. With the proliferation of internet-enabled devices and services, the need for faster and more reliable internet will only continue to grow, making fiber optic technology an essential component of our digital infrastructure. As we all know, as technology continues to evolve, it it is likely that we will see even more ways in which fiber optic technology will shape our world. These are my references which I uh, used to create this seminar presentation. And thank you.